This is Unit 5A, video number 5 on linear and nonlinear functions. Linear functions have the following characteristics. A graph that is a straight line, which should make sense because the word linear has the word line embedded right in it. Straight lines have a constant rate of change, which is called slope. Slope can be found by comparing the ratio of the change in the y values, symbolized by this triangle symbol, which is the Greek letter delta, so this is called delta y, to the change in the x value, which is delta x. So slope, which we use the letter m to symbolize, is the change in the y over the change in the x. And lastly, linear equations are written in the form y equals mx plus b, where m is the slope, a constant slope, and b is the y-intercept. Nonlinear functions have the following characteristics. A graph that is not a straight line, which again makes sense because it says non-linear, or in other words, not a line. Therefore, there is no constant rate of change or slope. And in equations, they are not in the form y equals mx plus b. They often contain exponents of 2 or more, a variable as an exponent, or x in the denominator of a fraction. Let's look at the examples below to identify whether the functions are linear or nonlinear. In this the first 3 examples here, we have graphs. So we are simply looking for a straight line. In this first graph, this is not a straight line, therefore this is considered nonlinear. In example number 2, we kind of have this check mark looking graph that is not a straight line, so it's nonlinear. And in example number 3, we have this straight line through the origin there that is, in fact, linear. For examples 4 and 5, we have a table, so we need to find the change in the y values and compare it to the change in the x values. So what we're going to do is we're going to go through and we're going to identify how these have changed. We're going to say that from 3 to 5, we went up by 2. From 5 to 7, we went up by 2. And from 7 to 11, we went up by 4. From 6 to 9, we went up by 3. 9 to 12, we went up by 3. And 12 to 18, we went up by 6. Now we have to find the change in the y value over the change in the x value. So that was our delta y over delta x. We have 3 over 2. And we also saw this 6 over 4. So we want to make sure that that is the same, similar to those proportional tables we saw in Chapter 4. We want to make sure that this is constant throughout the entire table. Don't just check one value. So 6 over 4 can simplify. If we divide by 2, it will simplify down to 3 halves. So this is constant. We had 3 over 2, 3 over 2, and 3 over 2. So this is an example of a linear function. In example number 5, we're going to go through and do the same thing, identify how it has changed. So the x value of -4 to -1, we went up by 3. From -1 to +5, we went up by 6. And from 5 to 12, we went up by 7. In our y values, from 3 to 7, we went up by 4. From 7 to 15, we went up by 8. And 15 to 23, we went up by 8. So right off the bat, I can see here, if I went up by 8 and up by 6 and up by 8 and up by 7, That is not the same, right, in those last two pieces. So this is non-linear because my rate of change is not constant. And then lastly, looking at these equations, I know that linear equations are written in the form y equals mx plus b, where there are no exponents more than 1, there's no variables as exponents, and there's no x's in the denominators. So looking at this first equation here, this is nonlinear because it has the exponent of 3 there. Example number 7 is also nonlinear because it has x as an exponent. And example number 8 is linear because it's written in the form y equals mx plus b, where the slope is 1. Please pause the video and try these exercises on your own. And I will go through and do them very quickly. So looking at the first 3 again, we have graphs. Very simply, we're looking for a straight line. So in the first graph, we have this parabola. This is not a straight line, so it is nonlinear. In example number 2, we have a straight line with a constant rate of change, so this is linear. Example number 3, that straight line there, this is also linear. With the equations in 5, 6, and 7, this first equation is written in the form y equals mx plus b, so it is linear. Example number 6 has a denominator of x, so this is nonlinear. And example number 7 has an exponent of more than 1, so this is also nonlinear. For the examples 8, 9, 10, and 11, I need to check the rate of change. So from 0 to 3, we went up by 3. 3 to 6, we went up by 3. 6 to 8, we went up by 2. 4 to negative 3, we went down 7. Negative 3 to 2, we went up 5. So that right there is not consistent, right? Down 7 over 3, up 5 over 3. That is a clear indicator that this is nonlinear. In example number 9, negative 3 to 1, we went up by 4. 1 to 5, we went up by 4. And 5 to 9, we went up by 4. Negative 1 to negative 3, down 2. Negative 3 to negative 5, down 2. And negative 5 to negative 7 is also down 2. That right there, that change in y over the change in x, the change in y was always down 2, and the change in x was up 4, so that is consistent. This is a linear function. In exercise number 10, from 84 to 5, we went down 79. From 6 to negative 1, we went down 6, and negative 1 to negative 4, we went down 3. From positive 1 to negative 1, down 2. Negative 1 to negative 5, down 4. And negative 5 to negative 9, down 4. The change in y, negative 2 over 79, negative 79, is not the same as negative 4 over negative 6, so this is non-linear. And the last table over here, from 6 to 0, we went down 6. 0 to 9, we went down 9. And negative 9 to negative 12, we went down 3. From negative 2 to 8, we went up 10. From 8 to 23, we went up 15. And from 23 to 28, we went up by 5. So now if we check this, we have the change in the y value over the change in the x value. We started with 10 over negative 6, which can be simplified down to 5 over negative 3. We had 15 over negative 9, which also can be simplified down to 5 over negative 3. And then lastly, we had 5 over negative 3. So those are all the same, right, constant rate of change there. So this is a linear function. And then the last exercise here we have is a situation So a verbal description here. John mows lawns. He charges his customers $15 per hour. A function relates the number of hours he works to the amount of money he earns. So this is a linear function because the rate is constant, right? He's earning $15 every hour he's working. If we were talking about proportional relationships, you would have told me that the constant of proportionality was 15. So the equation of this would be y equals 15x.